So Primev's vision is to focus on use cases that increase MEV vectors, but in a way that creates network welfare.
Hey everyone, welcome to another episode of Coordinated. Uh, I think all of you who are following us, following my yaps on Twitter or like the Coordinated page, you guys have seen about all the great things EigenLayer doing. Like it's not just me evangelizing about the protocol, but it's actually unlocking a plethora of new use cases and innovations. We'll see like more of that in lots of episodes, but today we have a special guest which using the power of EigenLayer trying to make Ethereum faster than Solana. So we have Murat from Primev, if I pronounce it correctly. And hey Murat, thank you for doing this. Thanks for joining in. And yep, welcome to the show.
Well, to be here, thank you for having me. We've been working on kind of the underlying protocol MEV-Commit that we've built for over a year now, and it's just really happy to and exciting to have it go to mainnet and kind of change Ethereum's landscape in a positive manner.
Mm. So before we going in all the, I think it's pronounced Prime V or Primev. Okay, Primev. So before we go deep into Primev and like some MEV-Commit, which I think I studied a bit before kind of jumping in the podcast, it's like all over. So I like to know like what bring you to crypto? Like what was your background before all these things?
Yeah, so I did grow up in Turkey, and my family's half American, so I've always had a sense of dollars and liras, and I always knew that none of them is kind of this canonical thing, and this just kind of value is always different for each perspective. So yeah, I mean, I was on Reddit when the Bitcoin white paper dropped, so it just immediately resonated with me. I'm like, wow, this is kind of like a new type of money essentially that's enabled by technology. And I saw the potential in there, but I never thought that it would kind of go towards the masses. I thought it was a little like too nerdy, esoteric for it to kind of become like this massive thing that it is today. And I'm happy to see that it has. But yeah, I'm a day oneer in that sense because I was immediately mining on my desktop at the time and trading and all of that.
Also, like, were you like before like crypto, did you into some other careers? I'm assuming you were mainly into software and technological fields only. So were you into some Web 2 kind of technologies, or let's say like from the beginning only you were in Web 3 and crypto tech?
I mean, when I was still very young at the time, so I hadn't. I guess in college or something, so I hadn't really started my career at that point. I was always interested in technology, but I always had like a finance hat on. Like I'm generally interested in financial engineering and financial efficiency and things of that nature, and I believe in using software for those purposes, rather than just stumbling upon a financial use case for software. So that's kind of what brought me in, and that's why I was hands on and mining and participating in the Bitcoin network in the early days. But I was really fascinated by the trading aspect of it, and the economics behind what eventually became tokenomics, right? So those kinds of financial aspects of the technology were what drew me in, and eventually, I was trading and everything, and it got to a point where I was like, well, I could teach myself some Python to just code this trading strategy, and that became kind of successful by some definition, and that led me kind of to lean in more and more and go hands on with technology more and more.
Awesome. I think amidst all this chaos and you making some good amount of money in Bitcoin and all this stuff, what like kind of like led you to start Primeape? Like what are the problems you saw in the space and then you kind of delved into Primeape?
Yeah, I mean, unfortunately, I didn't keep all of that Bitcoin, right? So it's still kind of going, but in that sense, I used my early kind of you know early winnings essentially to start a social wallet company. So this was called Myriad in 2017, and I wanted to create like a social onboarding experience for crypto. And while creating that, I encountered many infrastructure related issues. Like there was just no infrastructure available that you could use to build an app like that. You just kind of had Infura and you could just do a few calls about the chain on it, and that was it. So that led me down this path of pursuing more infrastructure and building more infrastructure. And, that led me to be, join Block Native as a product lead there. And there we, had a mainnet block builder and a relay and other things. And, engaging with people who are using our block builder, MEV searchers and others, led me to kind of to the insights that led to the founding of Primev, right? So people were looking for guarantees to be in the next block that was being built. And, as someone that was building about 15% of mainnet blocks, 85% of the time we could not give those guarantees, right? So I put forward this idea of what if there was a network that could give these guarantees, and all of these block builders that have fractional portions of the space could join the network. And that resonated with a lot of people, and who kind of encouraged me to pursue it, and eventually became Primev, and now MEV-Commit is going live on mainnet.
So I'm assuming like MEV-Commit is like one of the many things which Primev has done or will be doing. So like before that, like how will you define Primev? Like we got to know the problem part, but like let's say okay, I have to define somebody what's Primev. What will be your answer?
Yeah, so Primev's vision is to focus on use cases that increase MEV vectors, but in a way that creates network welfare. Right. So pre-confirmations is one flavor of this. It's essentially some sort of MEV that did not exist prior to us kind of putting this forward and building these mechanisms, and et cetera. And now it does. And now, many actors across the network gain benefits from it, right? So one of our focuses is to make sure that it leads to network welfare, meaning everybody is kind of better off by enabling this, right? So now the user can pay a little extra and get some value in exchange by having these instant transactions, and the actors across the supply chain, such as block builders and validators, can enjoy potentially more yield or revenue. And solvers have more volume, et cetera, right? So these types of use cases are what we will continue to enable on Primev, and pre-confirmations is kind of it's almost like a done deal at this point from our point of view. It's just a matter of adoption, but we're working on the next awesome network welfare increasing, MEV use cases.
So if I understand correctly, MEV-Commit is like kind of in the process of going to mainnet, and you have other plans basically to solve all this intent solver and the block things and everything, right? Like more products will come up from Primev, if I'm getting it correctly.
Yeah, you can definitely anticipate more products from Primev. Now, at the time, we're focused on proliferating MEV-Commit, and MEV-Commit is a platform. I mean, there is a high throughput chain, so you can anticipate also more products on top of MEV-Commit as the platform. So yeah, we will definitely increase the use cases of different types of MEV that proliferate network welfare.
So I think like as we anyway bring up the topic of MEV-Commit, I think that like this podcast will be mostly around that, because I'm hearing lots of good things about MEV-Commit in the Eigen ecosystem. Personally, I have the little research I have done. It's like everybody like in the Primev docs in the Twitter. Okay, we have MEV-Commit. So like now I want to like kind of take the cat out of the bag. Like what's MEV-Commit, if you can define it?
So, when you think of MEV on Ethereum, especially with the merge happening, it's predominantly PBS and the pipeline that was established by Flashbots, which is MEV Boost, right? So you have this.
Just interrupt you once. Like, can you please like define PBS a little bit so that we follow up properly?
Yeah, so proposer builder separation. The goal championed by Vitalik and many others in the ecosystem was, as we transition to proof of stake, how do we disintermediate the sophisticated block building process such that we can maximize the number of nodes that are validators and have them be as unsophisticated as possible so that we can achieve maximum decentralization of the network, right? So therefore, the community elected to do a trade-off where we ended up with somewhat of a concentrated block builder market, but we have maximum decentralization on the validator market, right? So the blocks that are proposed by, million plus validators at this point are built by a kind of a small group of block builders. So that's kind of what PBS enabled, this market for block building that validators could just consume and get a block and just propose that to the network, right? So we think of MEV-Commit as a layer on MEV Boost, right? And it's kind of a passive layer in the sense that the validators don't have to do much or run any additional software or fork MEV Boost or something like that. We kind of inherit some of the same ethos where any sophisticated actions are done by block builders and relays, and validators can kind of just enjoy the benefits. So that's how MEV-Commit was constructed, and it has an encrypted peer-to-peer network and a high throughput blockchain that allow for things like pre-confirmations.
If I understand it correctly, is a separate blockchain layer like MEV-Commit? Is it?
Yes. Now, it's particularly oriented around what's called fast games for Ethereum. So fast games, defined by Barnaby from the Robust Incentives Group, is essentially games by construction, but by which the chain does not have access to by construction, right? So if you have a 12-second block time on Ethereum, you can't do actions that are faster than that, right? So these are what's defined as fast games, and we position MEV-Commit chain as this kind of fast games chain, where you like there are startups that are looking at use cases where they essentially get a pre-confirmation on Ethereum, take a transaction to their rollup, process some information or some transactions on their rollup, and come back to Ethereum all within the same block, right? So it allows Ethereum to perform kind of faster than itself. So it's a really interesting paradigm because of that.
All right. So I think one thing which is like you guys have really stressed on, at least in the marketing front or in this the communication front, is the pre-confirmations of I didn't know or like get it properly to a separate blockchain. I was thought okay, it was some sort of like a middleware or something which is doing pre-confirmations. I think if we shift towards that, I want to know before we dive into pre-confs, kind of if you can define the transaction life cycle of in Ethereum chain particularly, and why you need pre-confirmations.
Yeah, definitely. So today what you're predominantly seeing is someone who wants to transact, usually sophisticated actors, or even if it was end users that use a wallet that goes through some sort of order flow auction, right? So let's say I'm sending you, or I'm trading 1 ETH for USDC, and that goes through some order flow auction. My transaction goes in here, and a searcher or solver kind of bundles my transaction, possibly with other transactions, usually with their transactions, and sends that to block builders. Right now, block builders see the fees in that transaction and the state that it touches and make a decision of including it or not. And then that block is then sent to relays, and relays, deliver that block to proposers who put it on the network. Right? So that's how the anatomy of a block is today. It kind of gets sourced through this transaction pipeline all the way on to the chain. Now, what the pre-confirmation allows is getting a guarantee in real time that that transaction is going to be in that block, right? So in this current regime, you find out whether you secured inclusion or not after the fact, right? So you see the confirmed block on chain and see your transaction made it or not, right? So it's kind of a wait and see regime today, where you're just kind of sending things and it's just silent for at least 12 seconds or so. And in many cases, it could be up to a minute. And then you find out what happened, right? So, and that transaction uncertainty causes anxiety in trading use cases, and it could cause losses and all sorts of other things, right? And the ecosystem is kind of thought of this as, hey, this is just kind of a byfactor of decentralization. It's something we have to deal with, right? And it turns out that's not the case. We don't have to deal with that. We can abstract that from the user. We can abstract that from even sophisticated actors, and we can provide these crypto economic guarantees in real time that will point at to what's going to be happening, right? And when you look at traditional payments or financial networks, this is how it works. for example, Visa. Visa gives you a pre-confirmation, right? When you swipe your card, you get a pre-confirmation, but that merchant doesn't get those funds probably till the next day or maybe 2 or 3 days in the future, right? And Visa has abstracted this kind of slow banking and money movement process from that end user, and that's what MEV-Commit does in the same sense, in that it just kind of abstracts the complexity and also the weight that you need to endure by having these crypto economic real-time guarantees.
So, like basically, correct me if I'm wrong, in layman's understanding, whenever I'm transacting in Ethereum blockchain, right, it takes a significant time for the transaction to completely finalized on the, let's say, the settlement layer of the L1, whatever we say. If we use a protocol or some software like what MEV-Commit or like Primev is, for now, the transaction will be confirmed quickly. That's the main goal, right? That is how we make the thing. Yeah.
So it will be confirmed roughly along the same time, but you no longer care about the confirmation. You receive a pre-confirmation, similar to how you like what you're trying to do at the end of the day, like in the Visa case, is, let's say, buy a bottle of water at the store, right? You don't really care about the payment. So once you get that pre-confirmation by swiping your credit card, you can now get the bottle of water, and that's the point, right? So you don't have to wait for the money to transfer. So similarly, you no longer have to wait for the confirmation. As soon as you have the pre-confirmation, you have that that crypto economic guarantee. Now you can do something. And a very practical use case of this is a bridge use case, right? Like, let's say I'm trying to bridge some ETH from Ethereum to Optimism. And now I have to wait for the Ethereum transaction to be included, which is, a minimum of few to 12 seconds. And then I might also have to wait for it to be finalized, which could be minutes, 10 minutes or not in some cases. And then, by the time, like, I just have to wait for so long to get my transaction. But if I just pre-confirm all of this, and also with reorb resistant pre-confirmations like the ones MEV-Commit provides, then you're just able to get your coins instantly on Optimism. So, like, as soon as you click the button to bridge, you will have the coins on the other side. And that's what the users care about. And then the actual transaction can confirm in 3 blocks, 5 blocks. You don't care. You already have your coins over here.
So, let's say there are like many, let's say, fast L2s, right? Who just quickly confirms your transaction, or let's say, but MEgaETH is promising, they're still not in testnet, ki, hey, we'll like give you instant things, instant confirmation, the real-time blockchains and all. So, how precons are kind of different than L2s?
Yeah, preconfs are mostly on the L1 layer, so they make L1 faster. So that's kind of the key thing. And this is not to kind of go against L2s or anything. L2s will continue to proliferate as well. But what you want is very quick interoperability with these L2s, right? Like, let's say MegaETH is there and it's super fast and it's great, but I have some ETH on Ethereum. And I don't want to wait 15 minutes to use MegaETH, right? And in some cases, I might, click use something on MegaETH and maybe bring it back to my protocol or my wallet on Ethereum. And I should be able to do that very, very quickly. And that's what pre-confirmations allow. And in many cases, once you have, pre-confirmations on L1 and also crypto economic guarantees on L2, where, let's say, the validators of the MEgaETH set can give you these guarantees at the same time, you don't have to wait for either chain. You could just get both of these commitments, what we call synchronous commitments, from 2 different chains or actors. And then your transactions on both chains will essentially be pre-confirmed in a somewhat atomic level. So it's really kind of unlocking different types of experience, both on L1 and across L2s.
Okay, so let's say for pre-con, right? For like with some complex technical things and all, we are kind of giving you, hey, before we are kind of abstracting away the 15 minutes. Just we click a button in milliseconds, your transaction is confirmed, right? Now I'm just guessing. I think is EigenLayer coming in that part? Ki, hey, if the validator network who has kind of confirmed your transaction, if they do any malicious activity, then the EigenLayer protocol will slash you. Is it something like that where EigenLayer is coming in?
Definitely. That's definitely a part of it. But the key part of it is, we need the validators. We don't particularly need them, but we ultimately want them to opt into this protocol because that makes the pre-confirmations as robust as possible, right? So when both the block builder has committed to something and the validator has opted in, you have kind of guarantees across the Ethereum supply chain that this is going to be delivered. And that's what you want. Now, validators could obviously go back on their word. So you need some sort of stake to be there so that it could be slashed if they don't hold their commitment in this case, right? So that's where EigenLayer comes in, because at the end of the day, validators have already put up 32 ETH. So asking them to put up additional ETH for these use cases is not applicable to every validator. Some are okay with it. Some are saying, hey, I've put up enough ETH here, so and I might not have additional ETH in some cases. So EigenLayer comes in to, one, bring native restaking to kind of reduce this, stake requirement, right? So you no longer have to have additional ETH. You can use your existing 32 ETH to restake for this purpose. And then obviously with the, slashing update that came about yesterday, you would be able to slash the validators. Now, in our case, we don't anticipate validators to practically ever be slashed unless they're acting maliciously. But that disincentive needs to be there so that they act according to the protocol. Right. So that's the key point. And yeah, in most cases, they will just enjoy additional yield from providing these services.
So basically, Primev or MEV-Commit is using EigenLayer for this purpose, right? Let's say running preconf nodes, validating those transactions. If you do any malicious activity, hey, you will get slashed. Is it how EigenLayer is getting used, or some other use cases are also there?
No, it's along those lines, but a little bit different in the sense that it's very passive. So if you're a validator opting into MEV-Commit AVS, you just use the relays that support this, and that's all you have to do other than natively restake your tokens. And block builders run the network and do the commitments and kind of do all of the sophisticated actions. So it's really promising in that sense that like anyone participating on EigenLayer just gets to kind of click a few buttons, and then all of a sudden they're supporting this really net new functionality that previously was not possible.
Cool. I think one question which I kind of had for a long time, I just Googled it out, used some GPT tools to get answer, but I want to hear from you. What is the actual difference between pre-cons and fast finality layers? Where do they differ, or what are the similarities they possess in the transaction life cycle?
Yeah. So, fast finality layers are definitely a good thing, and you can use some of the crypto economic guarantees that MEV-Commit provides as a fast finality as well. But ultimately, like it's more of a question of whether you're scaling L1 or, you're using something like an L2. And in the MegaETH example, for example, you might have your transaction confirmed very, very quickly. And confirmations are still more powerful in some aspects than pre-confirmations, because now you can use those tokens to do something else, right? So, but pre-confirmations can provide those same functionality as well. Where, let's say, I know that my approved transaction is pre-confirmed. Now I can send my swap transaction, even though the chain is not up to that state yet. I know that these can be kind of sequentially executed on the chain. So I, as a user, if I have a pre-confirmation on my approved transaction, now I know that my swap transaction can go through. So I can still act as if these are confirmed. And in the reorg resistant kind of guarantee cases, it's actually stronger than confirmations, because confirmations can still be reorged, right? But if you have this pre-confirmation, then you have a guarantee from the block builders that if the chain is reorg, they would build the same block with the same transaction in there. So you have this kind of peace of mind that your transaction is not going to be affected by the reorg.
Hmm. I think how pre-confirmations work and all this, like let's say all these parameters on the PVS front and everything, I think that needs to have a more technical mind or a dev mind to comprehend. So I'll not go deep in that, at least for today. I'll just want to go deep into one thing which you just we were discussing before kind of recording the show, and you just mentioned, hey, we actually want to make Ethereum faster than Solana. So just want to know about you, how you are kind of aiming to do that, because ultimately I'm hearing from lots of L2s that say, if I again point MEgaETH, like they're also like, yeah, we are just giving to you this super fast blocks and this super fast latency and everything. So want to know how like Primev is trying to do that, like making Ethereum faster than Solana. What's the approach?
Yeah, essentially, you may receive these commitments within 20 to 30 milliseconds from all of the network actors, right? And maybe let's say it's the worst case scenario, it's 500 milliseconds. It's still a sub-second experience for somebody transacting on Ethereum. And this is L1, right? They're not on an L2. Today, you still would have fragmented liquidity on L2. You don't have full interoperability. You have the bridge problem, as we kind of discussed. So you wouldn't have to kind of deal with any of that. Now, the L2s are also creating their own ecosystems, which is great and wonderful. And there's other commitment use cases for L2s as well. But this essentially scales Ethereum L1 in a way. And, we've talked to many kind of power users or funds that have, lots of value at stake, right? So they might have $1 million portfolio, 10, 100 in some cases. And those people are very hesitant to, let's say, put $100 million on a bridge to take it to an L2 in many cases, right? So they actually find assurance in the fact that their funds are on L1 and they get direct security from L1. So you still have a lot of L1 use cases on Ethereum that can benefit from these instant transaction experiences. And in many cases on Solana, for example, the chain is very, very fast, but your transaction execution rate is a lot lower than something like Ethereum. You might have to kind of adjust your transaction parameters, pay 5x the priority fees, and hope that your transaction will go through. In many cases, you will experience failed transactions, especially in state contentious trades where some meme coin is blowing up and you're trying to trade it and it'll fail and it'll fail again, it will fail again, and finally it will go through. And that's ultimately not a great experience. Even though it's fast, you're just failing fast. So what you want to do is get these execution guarantees in real time. Now, it may, in some cases, be expensive to get these guarantees on Ethereum. And in other cases, you might not be able to get them. But in the cases where you are able to get them, it's a fantastic experience. You get an instant experience and everything goes through. And it's just like as good an experience can get, essentially transacting online.
Understood. Cool. I think we now got an overview of the Primev product. I think it's not a very technical overview per se, but I think our conversation can help a dev to at least, let's say, okay, let's read the docs or let's see what they're actually building. I think that discussion we had. I'll now like to have a discussion about the use cases of the Primev protocol, because ultimately we are building towards that. We need developers who will be building all these AVSs or protocols or whatever. So want to know from you, what are the use cases or kind of new use cases which Primev or MEV-Commit as of now is unlocking?
Yeah, pre-confirmations is obviously one, but there's use cases of pre-confirmations as well. We went over the bridging use case. There's a lot of use cases around searchers and MEV searchers and solvers, kind of using pre-confirmations to reduce risk in their operations. And people might build order flow auctions or other kinds of end user related ways to express pre-confirmations using MEV-Commit. So let's say you can build an order flow auction and you can put that, you can integrate that with a wallet. And now the user using a wallet, just transacting on Ethereum, will have a very, very fast, experience and transacting. So these are kind of immediate use cases that will be available over the next few weeks as we kind of roll this out on mainnet and have adoption, right? So, but that's very exciting, and that essentially makes Ethereum super fast. By halfway through 2025 or end of 2025, we anticipate all bridging from L1 to practically be instant. So you no longer should have to wait when you're bridging funds from Ethereum. And that's kind of a game changer, both in terms of availability of liquidity, in terms of experience, and many other things. Now, moving forward, we're going to look at more multi-block MEV and other kind of MEV use cases where we can, again, provide some network welfare without kind of centralizing things too much or disrupting the existing landscape in a meaningful way. And these are kind of some early stage thoughts at this point, but these are things that the platform MEV-Commit enables. You can launch a contract and you essentially have the Ethereum supply chain programmatically available to you. And that can just unlock many things for developers to build, some of which I mentioned here, some of which I'm sure are yet unimagined.
Any projects which currently are building on Primev Preconfs, which we can talk about?
Maybe not publicly yet, but I can definitely mention. I mean, the bridges I talked about already. So you can think of your favorite bridge, and you might already think that they're looking at pre-confirmations. Also, DeFi protocols, large DeFi protocols that are that have solvers in them, etc., who are interested in making their solver operations more efficient, reduce the risk related to failed transactions, or just kind of unnecessary capital that they have to keep across L2s, etc. They can kind of reduce these with these pre-confirmations that make chains interoperable to some degree. So I would say those are some of the large ones, and then there are some roll-ups that process transactions very quickly, and they're looking at use cases where they can pre-confirm a transaction on Ethereum. They can process the transaction or trade on their rollup and then return funds back to Ethereum all within the same block, right? And for them to operate in this way, they need these guarantees that are real time, such that somebody can have an experience that is super, super fast, and it gains the liquidity that is, or some tokens that are available on another chain, without kind of having to leave Ethereum in the sense that, that from their point of view, they kind of quickly leave and come back. So it just enhances Ethereum's capabilities in terms of speed, and also kind of the design space for what you as an app developer can build.
Awesome. I think for all this to get enabled, we need kind of the mainnet. So that is the inevitable question, like when mainnet?
Great. So we've already launched our validator contracts on mainnet. So validators are already kind of onboarding on mainnet. And over the next few weeks, relays and block builders will also enable. That way, you have the supply chain of Ethereum already available on this network. Now, once that is available, then these protocols can build their use cases, and eventually all of these capabilities can be available to end users, etc., as well. But in terms of when mainnet, we're already on mainnet, which is wonderful. But the rollout is in phases in terms of actors adopting it, because it's not a network unless you have all of the actors on there. And that will take a few weeks, if not, maybe a month or two. But it's a very positive development in that. We've been on testnet for close to 8 months now, in various phases, obviously different phases of testnet. And we've gone through waves of audits, including, Cantina competition with $65,000 in prizes that have gone really, really well, and that have all prepared us for going on mainnet. So we made that announcement at our event in DevCon that, contracts are now on mainnet, and over the next few weeks, the rest of the system and the actors will be onboarding.
Awesome. I think before end of wrapping up, want to know that one thing that is MEV-Commit is the only focus of the next 2 quarters for in 2025, or you have other parallel products which we can see, which will slowly roll out?
That's a fantastic question. There's definitely some efforts, although we're very focused as still an early stage startup, to make sure that MEV-Commit is as successful as it can be. But there are emerging efforts that we're exploring with other teams that may manifest as products that are kind of built on top of MEV-Commit. So definitely, stay tuned in terms of what comes out, and particularly in the ABS landscape. EigenLayer increases the design space for us to build these kinds of products because of the security available and the operators that are available. And we can definitely leverage these two factors, the availability of operators, to one, further decentralize our system, and two, enable new things that weren't previously possible, particularly across the PBS pipeline that I mentioned, right? So we're going to be, announcing more things along this, and I can't wait for that. But it's at the same time, it's a little bit too early. So I would say look out around Q1 or Q2 of next year to see what those are.
Awesome. I think before, like in every episode, we just do a quick rapid fire. Like I'll ask you 3 questions, and you have to answer like all the questions under a minute, and like that's sort kind of last phase in the entire episode.
Love it.
So yeah, so just you don't need to answer in let's say 10 seconds, but you can take 40-50 seconds, but less than a minute. That's the all goal. So first question is what is MEV-Commit?
Oh, MEV-Commit is the pre-confirmation layer of Ethereum. To say it just very quickly, it makes Ethereum fast, and in many cases faster than Solana.
How MEV-Commit is making Ethereum faster than Solana?
Yeah, it provides crypto economic guarantees in real time that allow you to essentially get guarantees that your transaction will be finalized or your transaction will be executed in a way that you're looking for, that allows you to kind of do other actions outside of Ethereum. In the example we gave, go to the store and get a bottle of water, for example.
Okay, the last question is 3 use cases MEV-Commit is unlocking for crypto.
Yeah, execution pre-confirmations, so real-time guarantees that your transaction will be executed in the way you're looking for. Instant bridging, which is a major unlock across the ecosystem, and fast interoperability with L2s.
Awesome. I think thanks Murat for doing this. Thanks for like giving us a kind of overview of MEV-Commit is. I think based on my research, it's a quite technical product. I think there need to be some technical head who is a dev, I think, or a dev rel proper, who can come and can ask you better questions, can get those answers out. I try to do my best job just getting the overview, and hope you enjoyed it.
Yeah, very much. Thanks for having me again. And as always, people can reach out to us or engage with us in various manners, and we're happy to enable them to make Ethereum fast with us.
Just one thing, where is the best place to reach out? Is it Twitter or Telegram? I will link the handle in the description of this.
The best place for the Primev _XYZ account. We always monitor our inbox, and many of our early users and participants have reached out on Twitter. So Twitter is definitely the best place.
Awesome, cool. Thank you. Yep.
Very much.